it says, what's the measure of an exterior angle? So exterior is when you extend a side. So in this case, we extended this side, and that side. If you extend the other sides the other way, you can also have exteriors, but it tends to go in the same way. So it looks like a pinwheel. So the exterior is on the outside of them, okay? You don't want the 180-degree angle that's on the outside. So when you extend a side, it's going to be the one that's smaller than the 180 degrees. So with these three angles, there are three angles on the outside. Inside, it's going to be different for every picture. But outside, no matter how many sides there are, whether you have 3 sides or 5 sides or 9 million sides, it doesn't matter. They will 100% of the time add up to 360 degrees. So you don't have to have a fancy formula like we did yesterday with the n-2 times 180. That's only inside. Outside, no matter how many angles they are, it's always going to equal 360. Okay, I know that sounds weird, but the more sides there are, the smaller the angles are. Okay, so if you have 100 angles, they're just going to be really tiny to add up to 360, as opposed to having 3 of them, where that's going to end up being 120, 120, and 120. Okay, now if you did these, if they're all equal, like it's showing right here, if they're all equal, you would just take the 360 and divide it by 5, because there are 5 of them. So in this case, you're going to end up with 72. So these are all 72s. These are all 120. So the more sides you have, the more angles you're going to have. So the more angles you have, the smaller they're going to be. Okay, so all you have to deal with today for exterior, as soon as you see that word, you know you're going to be using 360 somehow. So if you see exterior, they always add up to 360. Okay, so that's what I just wrote here. That's called the polygon exterior angle sum theorem. So 100% of the time, exteriors will equal 360. So if it says find the measure of an exterior angle of a regular polygon, because the first handful in the IXL, that's all they ask. So you don't even have to think. If you want the measure of all of them added up, every time it's 360. Now this one says an exterior angle. So you have to see if it says the sum. If it says the sum, then it's 360 every time. If it says an exterior angle, that means they only want one exterior angle. So if that's the case, we're still talking exterior, so we're still talking 360. Pentagon is going to give me 5 sides, so that's the one I was just doing up there. You just have to cut them, and since it says regular, they're all equal. So you just have to cut it into 5 equal angles. So that's what I was doing up there. That's 72 degrees for this one. Okay, for a 36-tagon, whatever, they all have a special name, but usually if it's more than 10 or 12, they tend to just put the number in there. So again, exterior is 360. We're going to divide it by 36. So if you have 36 sides, then every exterior angle is going to be 10 degrees. Okay? All right, over here, it says find the measure of an exterior angle of a regular pentagon. So in this case, yes, I can just do this. I know there's going to be 5 of them. I know it's going to be 72 degrees. So that is one way to do it, is just like that. Another way to do it, some people can't think like that since you don't see all 5 of them. But if you wanted to do the interiors, you could do the 5 minus 2 times 180 like we did yesterday. So that's going to be 540 total inside. And if you divide that by 5, this is what we did to get a single interior angle. So you had to do a whole lot more work to get the interior. This would have been 108 degrees for all of those. And since those two make a straight line, you can just take 180 minus 108 and get 72. So this is just an alternate way to do it. Obviously, this is easier and faster, but just to show you that there's 2 different ways to do it. Okay? The reason why I show you that is for problems like this. So they ask you to find the value of the variables. Well, everything is a variable. So I can't figure out X, Y, and Z. I cannot figure out the interiors until I figure out the exteriors. If you notice, all the exteriors have the same letter, so we want to go there. And if you have exteriors, they're going to add up every time to 360. This is not a regular picture, okay? So it doesn't tell me that it's regular. It doesn't show any equal angles, so that doesn't mean these are all equal. They obviously are not. They have different measurements. But I know that Z minus 13, and Z plus 10, since they're all 3 the exterior angles, they're going to add up to 360. So anytime you see something with exterior, you're going to do something with 360. So I've got 3 z's. Negative 13 and 10 is negative 3. So I'm going to add 3 over here and then divide by 3. So z is 121. So now that gives me the z for the variable. Now I can find w because these two equal 180. So if I plug in 121 right there and subtract 13 from it, that's going to give me 107, right? No, 108, sorry. So that's going to give me 108. And then to find w, I just subtract from 180 because they make a straight line. So that makes w 72. And then again, I can do this one up here. This is 121 and they make a straight line. So 180 minus 121 is going to give me x, which is 59. And then I can do the same thing over here, or I can subtract from 180 right here. It doesn't matter. If I do 121 and 10, that's going to give me 131. And if I subtract from 180, because those two make a straight line, that's going to end up with 49. So those are all my variables, okay? All right, this one, I'm just trying to give you a different type of example for every single one. How many sides does a regular polygon have if every exterior angle is 24? So what that means is usually we divide it by the number of sides, which we've been calling n, so I'm going to stick with that. And they're telling me that usually gave me 24 degrees, okay? So that's because I knew to use 360 because it's at exterior. It's regular, so they're all the same. I just divide it by the number of sides, and it gives me one of them. So if I do this, excuse me, what I can do to solve is, remember when there's a variable on the bottom and a number by itself, you can just swap them. Because basically to solve, what you're doing is timesing by n. And then to solve for n, you would divide by 24. So if you do 36 divided by 24, you're going to get 20, I think it's 15. Okay, so that would be 15 sides. So sometimes they'll ask you for the number of sides and you have to work backwards. Okay? Down here, measure of an exterior angle is given. So this is one exterior angle. It says find the measure of an interior angle. Then find the number of sides. So if I'm looking for an interior angle, remember that an exterior and an interior are going to add up to 180. Okay, they always make a straight line. So if I do the 180 minus the 72, that's going to give me 108 degrees. So that's going to be an interior angle. And then it says find the number of sides. So now what I can do, again, I had the exterior divided by the number of sides give me 72. They said the measure of one exterior angle. So one exterior angle is 72. Again, you can just swap them. So if you just do, all right, let's do this. 360 divided by 72. It's going to give me 5 sides. So those are the two things that one asked for. Okay, so it's just different ways to ask these questions. I'm trying to show you a different kind of example for each one. So something like this, it says find the value of the variables for each regular polygon. You got to watch out for that. That shows me that everything's equal. Round to the nearest tenth. 1, 2, 3, 4, 5. I didn't notice that all my examples had 5 sides in here. That's just a random coincidence. So if I'm looking for that angle right there, exterior is the easiest to deal with. So I'm starting there. I don't even mess with A. So if I've got 360 and I'm going to divide it by the number of sides, that's going to give me what B is. So in this case, again, I'm going to get 72 degrees. And then to find A, since it's regular, that means all of these inside are going to be the same thing. So you can just subtract from 180. They make a straight line. So if I do 180 minus 72, that's going to give me the 108 for letter A. I guess I could do a different one so that it's not the same numbers every time. So this one over here, exterior is the easiest to deal with. So 360 divided by the number of sides, which in this case is 3. So that's going to give me 120 degrees for X. Then same thing, if it's regular, then that means Y is going to be 60. I just take 180 minus 120, and that's going to give me 60 for Y. Okay? You could have done it the other way like we did yesterday. Yesterday, for the interiors, you would have done n minus 2 times 180. So obviously, you don't need to do that for a triangle. Everybody knows a triangle adds up to 180 on the inside. And then if you take the 180 and divide it by 3, that's going to give you 60. So there's a couple different ways to do some of them. If they're asking for both, you get to choose. I always think exterior is easier because you just deal with 360. So that's all exterior is about. Now we're going to move on to symmetry. Rotational symmetry, I'm not going to put on your test. I'm just throwing it in here so that you can see what it is. Plus, it's kind of neat. So if you have rotational symmetry, that means it can be mapped on itself with a rotation of 180 degrees, meaning if you flip something upside down, it's going to be the same thing. So in other words, see this word Henry right here, this name Henry? If I flip it 180 degrees and turn it completely upside down, it is the exact same thing, Henry. Okay, so it's kind of neat for the rotational symmetry. Here's Aerosmith. I did not know this, but if you take Aerosmith and you flip it upside down, it still says Aerosmith. So this has rotational symmetry. Okay, this one right here, same thing. So all of them, when you flip them upside down, they're the exact same thing. Okay, same thing here with this little flower. Flip it upside down, same. And then this one right here. This one would have to go a full 360 for rotational symmetry, because if you put it upside down, it's not the exact same thing. But it also says that you can do or less. So let's just say I did 90 degrees. Now it's matching. So if I did another, so it doesn't have to be a full circle. So if I can turn it in any way, if I can just turn it to match it like that, so now it's matching like it did before. If I can just turn it a little bit like that, it's still matching. So this one doesn't have to be a full 180. It can just be something less like that than 180. So right there, again, it's matched. These are 180 degrees. These can be less than, so it can be less. Now, the one you're going to see on your IXL, and I'm going to show you a few examples on how to do it in IXL as well, because it was kind of weird when I looked at it. So when you're doing line of symmetry, it splits a figure in half. So it's like putting a line and folding the picture and it would match up. In other words, if I did, let's say I did this one right here. So right here, this would be a line of symmetry, because if I fold it on the blue line, everything is going to match up. Okay, that's the only line that I can do. All right, let me pick a better line. Here, we'll do this. All right, now with this one, there are multiples you can do right here, and it would fold in half and be perfect. Okay, that's one. You could also do, let me get that back. But you could also do this one and fold it, and it would work. Okay, so there are multiple ones on some. This triangle, it only has one. Because if you went from this line and you folded it, this would be further down here. These two pieces wouldn't match up. So that's no good for that one. But this will work for the square, although you can't see it. Let me do a new one. So if I did it for the square and I went from corner to corner, that would work. So these would match up. You can also go from this corner to this corner, and those would match up. So this one actually has 4 different lines of symmetry. If it is a regular picture like this square, you can have a line of symmetry from the corners and from the side lengths. Okay, this one, if it's not regular, you're probably only going to get one. Now look at this triangle. This triangle is regular. So you're going to have one here, and one here. So when it's regular, you're going to get them from the corners, either corner to corner and side to side if it has an even amount of sides, or if it has an odd amount of sides like the triangle, you're just going to go corner to side. So this one has 3. This picture over here, you can't do a vertical one. It's not going to match up. Okay, you can't do, if you do a horizontal one, it's not going to match up. This dot, if you folded it, would be down here. No, it wouldn't match up with this one. So the only ones that are going to work here are the diagonals. Now, if you do that, they're going to match up. Same thing with this one. Okay, so you're going to only have 2 in that one. Down here, again, if it's regular kind of looking like this, if you go in half here, this is fine. Okay, and then if you go here, that's going to work. So this, again, it has 5 sides. So if it has 5 sides, you're only going to go from corner to side, corner to side. So every corner to side length is going to work. Okay. Weird pictures like this right here, this is the only one you're going to do. You can't go across, you can't go diagonal. That's my only one. Okay, and then finally for my X right there, I'm going to have the one down the middle. That'll match up. That will match up. And then this works as well, because if I folded right here, everything's going to match up. And that will also work here. Okay, so some pictures have more. If you have a weird picture where the thing is off, usually you're only going to get one. Sometimes you can get none if nothing would match up. Now, the last thing I want to show you is in the IXL, because it's kind of weird. They want you to draw the lines. So when you get to this, it says draw the lines of symmetry for this shape. So what you have to do is you have to start somewhere on the picture. You can't just draw a line like you want. So they want you to pick a dot, and then it'll give you a line, and you have to go to another dot on the picture like this. So this would be my only line of symmetry. So I submit, they're happy. And then here, this would be my only line of symmetry here. Nothing else would match up. Okay, so you're going to get things like that. Here to here. You just have to remember to make your line. You got to make the dots on the picture. They want you to do it like that. Okay, so obviously this is really easy. I just got all the way up to a 28. So with this one, I'm making you get to the full 100%, because once you start skipping to them, we've got this one, and I need another one because the one going sideways is going to work. So I hit the plus sign, and then I can do another line like this. Okay, and for this particular one, I don't think the X is going to work with this one, because you can't go the sideways. I don't think you can. But I'm going to skip to the next level. I don't want to give you too many answers. Let me get to this one. So once you get up to a 96, sometimes they'll give you regular pictures. So when you get these, you got to go corner to corner. I know I'm going to do that. So I'm going to add another one, corner to corner, because this has an even amount. And this corner to this corner. Now I also have to do side length to side length. Okay? And you keep adding them, this one to this one, and finally this one to this one. Oops. If you mess up, you can just click the dot and it'll undo it for you like that. So that'll be something along the lines that you'll see. Okay, so those are going to be the ones you see at the end where you have to add the lines.